Evening guys, we're back with another problem, and today's problem is a maximum connected graph problem and also known as the island problem. So I've been solving GFG for since last 150 days, and I would say this is the best problem I have faced till date. A problem which will open up your mind, which will blow up your mind, and it will make you learn a lot of new concepts. And it's just so fascinating how the people make such problems, and these problems are really amazing. Okay, so without any ado, you go like, share and subscribe to this channel. It's been a long time and I want as many people possible to watch this particular video. So first is, what is a maximum connected group, how it's known as the island problem, and how dynamic programming and all kinds of logics can be implemented in solving this problem. So firstly, we have been given a grid. Okay, so we are being given a grid. Okay, we have been given a grid. Okay, and the grid should have values. Grid should uh, should have values 0 to 1, means 0 and 1. You need to find the largest connected group of ones. Find largest connected group of 1 okay, and two cells are said to be connected if both are adjacent top left border to each other and both have the same value. So two cells are said to be connected if both are adjacent in all four directions, and both have same value. Okay, so let's take an example of the grid 0 1 0 1. Okay, now by changing any such value, we can obtain a grid as we can obtain the grid 1 1 1 1, and the size of this grid is 4. Okay, because there are 4 ones which are connected, which are made interconnected. Okay, so this problem can be solved. Let us visualize another grid. Okay, so say for example 1 0 1 1 1 0 0 1 1. How you are going to change one component in order to get the maximum component? So if I change this particular 0, then what you can see is I will get a 1 1 1 1 0 0 1 1 1. So now this problem becomes interesting, as the maximum connected component I can get is this region. So total number of count is 1 2 3 4 5 6 7. So my answer will be 7. This is what I have to return. Okay, so how I'm going to solve this particular problem? So this particular problem can be solved using the concept of depth first search. Okay, using the concept of DFS. So DFS will allow me to check whether my left and right and top and bottom I can traverse in all directions and check whether the values are equals to 1. Okay, apart from that, what else I'm going to do? Apart from that, I'm going to use the concept of island number. Okay, island number. So if I use the concept of island number, what I'm going to do is, initially there will be zeros and ones, right? But I will set the island number as 2. So, and there will be a hash map. Okay, and the hash map of integer, which will have a key and a value. So in the hash map, my first task will be to store some values, right? So initially, whenever I'm getting a hash map as 1, what I'm going to do is I'm going to make this one as 2 2 2. Okay, so I'm making the island number as 2. So when I have the island number as 2, the largest size I can get from here with island number 2 is 3. Similarly, I'm going to increase the island number track, the island equals to island plus 1. So if I do this, when I'm coming to the next value, what I'll make this as 3, okay, 3, 3. So I will get the island with 3 and their maximum size is also 3. So this can be dealt with the concept of hash map. But now what else is required? There should be also a hash set, okay, a hash set of the type integer. Okay, what this hash set is basically going to do is it's going to check whether its adjacent values. Suppose you are standing over here. Suppose you're standing over here. You have to check in this direction, you have to check in this direction, this direction, and this direction. If all 4 directions are satisfied, what you're going to do is you are going to do the summation of the answer, and you are going to return and store for one particular cell the size. Similarly, when the size is being updated, you will get the total size as 7, which is 3 plus 1 plus 3. Okay, so this is how we are going to solve this particular problem, but this requires a lot of information, so we are going to go on the algorithm part of this particular problem. Okay, so I'm going to quickly write the algorithm. Okay, I'm going to quickly write the algorithm of how I'm going to solve this particular problem. Okay, so I'll be having a public int max connection. Okay, int max connection. Say for example, this is the maximum connected graph. Okay, so I'm giving it a function as max connect, and I'm passing a grid into it. I'm passing what? A grid, a 2-dimensional grid. Okay, so in this grid, what I'm basically going to do is I'm going to first take the size of the grid, n equals to grid dot length. Okay, similarly I'm going to initialize the island number, so I'm going to take an island equals to 2. Okay, and I'm going to store my values, so I'm going to store hash map integer, okay, map equals to new hash map. Okay, so in this hash map there will be also a component called the answer. Okay, what my first task is to traverse through the given matrix. Okay, so what I'm going to do is I0 to n I and plus plus of I. Okay, similarly for the columns, 0 to the length of the matrix plus plus of j. Okay, now as I told you, whenever I will be encountering 1, so if my grid of I and j becomes 1, okay, if my grid of I and j becomes 1, what I can do is I'm going to compute the size, right? So I'm going to store size equals to DFS. So now comes the DFS function. Now why I have to make a DFS function, right? So in the DFS, I'll pass the grid, I'll pass the I, I'll pass the j, I'll pass the size of the matrix, and also the island. Okay, and for each I will do map.put. Okay, map.put, I'll put the island along with its size, particular island. First island is 2 island, then island will be 3, which I have already told. You can go back. And lastly, in the answer, we are going to store the math.max of the answer and size. Okay, and we are going to increase the count of the island, so island plus plus. So this is for now, but there will be a hash set involved. But before going with the hash set, what I'm going to do is I'm going to quickly create the DFS function, because I'm using a DFS over here, right? So over here, what I'm going to do is I'm going to create a DFS function which is going to return the size, right? Which is going to return me my size. So in the DFS function, what I'm going to do is int DFS. Okay, and in the DFS function, I'm going to pass a grid. I'm going to pass the grid. Okay, what else? I'm going to pass the I, I'm going to pass the J, I'm going to pass the island. Okay, there's several parameters, because when you become good, when you become pro in CP or competitive coding, then you know that there are a lot of parameters you have to adjust accordingly. Okay, now I'm going to do the base cases, like whether my rows is lesser than 0, whether my column index is lesser than 0, whether the value is lesser than 0, value is greater than 0, if the island is the island itself. So there are a lot of constraints. Okay, so my first condition is the base case check. Okay, so if the I is greater than 0, or J is greater than 0, or my I is greater than n, or my grid value of I and j is equals to 0, or my grid value of I and j is equals to the island. Okay, so these are the base cases. In all the cases, I'm going to give a return check as 0. Okay, so these are my base cases. If the base cases are satisfied, then 0. Okay, if the base cases are not, if they have some other value, then what we are going to do is we are going to give grid of I and j equals to island number. Island number is nothing but 2 in this case. Okay, and the island number will keep on increasing. So after that, I'm going to find the coordinates of A, B, and C, D. So I'm going to define A, I'm going to define B, I'm going to define C, I'm going to define D. These are nothing but top, down, left, right, like that. Okay, so first task is I'm going to call the DFS function recursively. I'm going to pass the grid. Okay, I'm going to first task is I minus 1. Okay, I minus 1, J, N, and island. So if you check in this case, what is I minus 1? I minus 1 is rows, and the same column is my previous value or left value. Okay, it's just the previous row, same column. Okay, so I can write it like this, like top value. Okay, and now for the second one, DFS of grid, I'm going to pass the values as I and j minus 1, I and j minus 1, n, island. Okay, island. So if I check now, I am in the I, means I'm in the same row but the column above. So I'm in the, say for example, I'm in this row, there are particular rows. Okay, I'm in the same row but I am in the previous column. I'm in the previous column, means I'm over here, right? Now we have done this, now we've done this. Okay, similarly we are going to have DFS of grid. What we are going to have? We are going to have I plus 1 and j, n, island. So I plus 1. So if for example, if we are over here, okay, what is I plus 1? I plus 1 means in the next row but in the same column. That means you have just come to the bottom. Top, I hope I explained it well. So DFS grid, okay, one right is remaining most probably. So it's I and j plus 1, n, island. So last case is, say for example, I'm over here. What is j plus 1 is my next column and in the same row. So this is my right value. Okay. So similarly, once I have done all the possible calculations, I'm going to return 1 plus A plus B plus C plus D. As I told you during my calculation of the islands, 1 plus the size of this, and this. So 1 plus this and this. Okay. I hope I could make you understand the DFS component. My DFS component is completed. Okay. Now let's come back to the main int connect component script. So once the island is being calculated, what my next task is, what my next immediate task for the day will be. So what I'm going to do is I'm going to traverse again, okay, I0 to n, plus plus of I. Okay. Similarly, I'm going to traverse to the j equals to 0 to n and j plus plus. Okay. In both the cases now, I will be having a hash set, which is nothing but checking the position and directions of the 0. So I will be having a hash set of the type integer. I will be having a hash set of the type integer equals to, you can write it as new hash set. Okay, new hash set. Now I'm going to check if my grid value, grid of I and j is equals to 0, means there is a 0 component. Now I'm going to do the hash map calculation for the zeros. I will do if I greater than 0, which means my rows, where row I am is greater than 0, the index of the row is greater than 0, then set dot add, I'm going to add grid of I of -1 and j. So what is -1? I already told with the previous row, but in the same column. That means the top element. Okay. Once I-1j is done, what next I'm going to do is I'm going to pass another if condition and check whether my I is lesser than n-1. In this case, my index is lesser than n-1, so I will be adding the set dot add. I'll be adding grid of I and j-1. So I'm in the same row but in the previous column. So this is nothing but my left value. Okay, so I've added my left value, top value, both are done. Last condition, what's the last condition? This actually, is it the last condition? No, there will be two more conditions. Right? So j greater than, I can say j greater than 0. Okay, j is greater than 0. Then I will add set dot add. I can add the components of the grid of I and j-1. So what is I and j-1? It's nothing but I'm in the same row but previous column. That means same row and I and j-1. I guess I did some mistake. I already did it once. So in this case it will be I plus 1. I'm in the next row and same column. So I just same column. Yeah. And over here I'm in the next row and the same column. So this is nothing but the down element. Okay. Similarly, j is greater than 0 is done. So I will be doing my last job for today is j less than n-1. In this case, set dot add will be my if I check the grid, so I'll be having a grid. Okay, I'll be having a grid of I and j plus 1. So it's nothing but I'm in the same row but this component means the right value. Okay, so once all the values are done, I'm going to close the loop and now I'm going to iterate through this set. That's why I'll need another loop. So this, these are all hard problems, so it will get complicated. It will get complicated, but you have to take maybe a year or maybe months to get hold of this, and it will be easy for you. So I can write max value, max length, okay, the max size, whatever it is, plus equals to, okay, plus equals to map dot get value of the sets equals to null or 0 map dot get s. So basically what it is doing is, if there is a null I will return 0, or if it is not null I will return s. Okay, then I'm going to update the max value counter plus plus. Now my answer is math dot max of max and answer. Okay, I will be completing everything. I'll be returning my answer and close the functions. So this is the most comprehensive, best quality explanation you can ever get in the areas of dynamic programming. So I would like you guys to go quickly subscribe to my channel if you haven't subscribed, and then we can go with the code. Okay, we are going to go with the code. So this is the code. If you see carefully, this is the code. What we are basically doing is, first ignore that. First we're going to have an int max connection. In the int max connection, what I'm basically going to focus is, in the x max connection, I'll be taking a grid length of 2. After that, I am taking the island length as 2. Grid length is the size of the matrix. I'm taking a hash map to store the island IDs and its size. Now we have to identify all the island IDs and store them in the size. So you know that I've already done is grid. If the value is 1, then in the size I am going to pass the DFS, and for that I have made a DFS function over here with first the base cases, then all the left and right and top and bottom movements. Okay, once this is done, we are going to update the size and store it in the answer variable. Now we have to check each cell, that is water. So if we have islands, there will be a middle water, and see if connected island increases the maximum size or not. So similarly, we are going to pass to the grid, and in this case the grid is 0. In case of a 0, we are going to have a set to store unique neighboring islands, the values of the nearby ones present across the zeros. Okay, now we have to check all the 4 possible neighbors and add their island IDs to the sets. So we are going to add the IDs. Lastly, we are going to calculate the potential size by connecting the neighboring islands. Okay, this is only valid when we are connecting the potential size. We are going to update, and lastly we are going to update the maximum size if needed, and then we are going to return the answer. So this was about today's problem statement, and I hope you could get a grasp of what a hard problem looks, and it will help you increase your thought process and do things better. Thank you, and I would love to see you in our next video. Thank you so much.